Okay, I'm going to do this assignment number 3 here. Constant velocity particle model, worksheet 3, motion maps and velocity versus time graphs. All right, so first thing, if you have not already watched the motion maps video, you need to go do that right now. It's in the one of the videos for, it's a material in our Google Classroom. It's with another video about with the solutions for assignment number 1. But there's a little notes video, it's not very long. It tells you about motion maps and what is that. And I'm going to make some here, and you should not be watching this until you watch that and tried them yourself. Alright, so I'm going to assume now that you have done that. So what do we want to do here? Sketch a velocity versus time graph. So that's not position versus time. This is a velocity versus time graph. And a motion map corresponding to the following descriptions of the motion of an object. The object is moving in the positive direction at a constant speed. Alright. Now they didn't say where it starts, so I'm going to start my object here at 0, but you don't have to because it does not specify where it starts. So you could start somewhere else. You could start at 1 or whatever. And it's going at a constant speed, so I don't know, it could be moving like 1 meter every tick. If you space these out, like made them closer or farther apart, that's fine. It didn't say how far. It just says that it's moving at a constant speed. So what I need is for them to be equally spaced. Then I'm going to make my little arrows that go halfway from one to the next. Good. Now, let's think about this. If it has a constant speed in the positive direction, well then its velocity is some positive number, and it's constant. It's not changing. It's not going up. It's not going down. It has a constant speed, and it's positive. Constant velocity. So that's what that's going to look like. And, I mean, this whole unit that we're doing is about constant velocity, right? So we should expect to see all of our velocity time graphs looking like this. If it's constant, then we're going to be looking at a bunch of horizontal lines, right? When we look at a velocity versus time graph. Now you got to watch out, because if you're looking at a position time graph, that is going to be some kind of line with a slope, right? With a non-zero slope. And then this, well, whatever the slope of the position time graph is, this would just be a horizontal line at that value. Alright, let's do some more. The object is standing still. Well, let's see, where is it standing still? I'll have it stand still, how about here? You could put it anywhere on here, it does not say. So remember, how do we do that with a motion map? We just make our dots like that in the same place. You don't want just one dot, because that's only one tick of the clock. We want the multiple dots to show that it's, as time goes by, tick, 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 it's still at the same location. If you're thinking, wait, but they're moving down, remember we're only moving back and forth on this number line, and these points underneath, like here for example, this is representing something that's moving along the line here. Right? So let's see. What's the velocity of this thing? Well, it's standing still, so the velocity is 0, so it's 0 and it's not changing. So it would just be right there on the axis. How about this? The object moves in the negative direction at a steady speed for 5 seconds and then stands still for 5 seconds. Okay? So I'm going to start over here, so I've got room to go this way. So that's time 0, and then what? Actually, you know what? I'm going to do these underneath, so I have more room. Here's time 0, 1, 2, 3, 4, 5, and then stand still for 5 seconds. 1, 2, 3, 4, 5. If you're looking at this and you're like, wait a second, that's 6 dots there. Time going by is like in between, that's in the in-betweens of the dots. So if we labeled this, maybe this will make it easier to understand. If this is time 0, then this is time 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How much goes by? How much time goes by between time 5 seconds and time 10 seconds? Well, 5 seconds does, and same between 0 and 5. Now I need to put my little arrows in. In there. The arrow points to the next dot, so you do not want to have a dot on the 5th second, which makes sense if you think about what's going on, because when the clock gets to 5 seconds, then that's when it starts to be motionless. All right, so how do we make a velocity time graph here? I'll make this the 5-second mark. So for the first 5 seconds, it has a negative velocity, so some kind of negative velocity that is constant for 5 seconds, right? Negative whatever. And then after that, for the next 5 seconds, it's not moving, so its velocity is 0. So I got two little bits of horizontal lines. Here's the negative velocity, and here's the 0 velocity. I would prefer if you don't connect these. I'm not going to freak out if you try to make a little connection there. It gets into issues about things and whether they're functions and whether that's vertical and whatever. So I prefer just to leave them like this. All right, number 4. Object moves in the positive direction at a steady speed for 5 seconds, and then it reverses direction and moves backward toward the negative direction at the same speed. Okay? So we could start it at 0. You don't have to. But 1, 2. So this is 0, 0. 1, 2, 3, 4, 5. And then it reverses direction. So by the time we get to 6, it doesn't stay here for a second. It doesn't say anything about staying there. So it's already going to be back here at time 6, 7, 8, 9, 10. It didn't say I had to do that for another 5 seconds, but why not? So, and you know what? I think I kind of messed up here, because by the time it gets to here, this is where it reverses. So really, I think if I want to be able to do my arrows, this dot should be here so that I can do that. That's time 0. This is time 5 seconds. That should make sense. That's where it switches right there. And then this is 10 seconds here. All right, now how about my velocity time graph? Well, for the first 5 seconds, here's my 5-second mark there, it has a positive velocity, constant positive velocity, and then for the next 5 seconds, it has the exact same, so this distance here needs to be the same as that. It would be wrong for that to look really close to the axis, and that was far away. It says same speed, so that's going to be the same spacing here, right? So if this was like 1, this would be like -1 or whatever. So it look like that. So again, constant velocity. Notice that all of these things are horizontal lines or pieces of horizontal lines. All right. Now, what does it look when we put these things side by side? Here's a position time graph. So what does its velocity time graph look like? Well, let's see. If I wanted to know the velocity from a position time graph, that's the slope, right? So the slope of this is, looks like rise over run is 1 over 1. The slope is 1 meter over 1 second, or you could say 1 meter per second. So the slope is, and notice here the units here, velocity in meters per second, it's 1. And it's constant. The slope of this, we're going at a constant velocity. The slope is not changing. The slope of this is not changing to different things. It has a constant velocity of 1. So if you make a velocity time graph, it's just 1, 1, 1, 1, 1. What's the slope here? It's 1. How about here? 1. What's the slope here? Still 1. So this is just 1. right? Here's one that changes at time 2. So here it looks like for the first 2 seconds the slope of this is 1. And for the next 2 seconds the slope is -2. And I don't have anything going on between 4 and 5, so I'm not going to do anything there. Right? So I'm just making horizontal lines at those constant velocities, and we can get that by just finding the slope of this, right? This went 2 meters from 2 to 4 in 2 seconds. That's 2 meters in 2 seconds, or in other words, 1 meter per second. And here this is -2 meters per second. How about this? For the first 1 second here, I've got a slope of 2. It's going 2 meters in 1 second. It's going 2 meters per second, but just for that first second. And then after that, looks like it's going 1 meter every 2 seconds, or half a meter per second. So let's see, that'd be at half, and that's for the rest of the time there. So there's my, sorry, a little messy there. Got a color inside the lines, like that. Okay, great. For many graphs, both the slope of the line and the area between the line and the horizontal axis have physical meanings. That's definitely true for us here. What does the slope of a position time graph tell you about the motion of an object? Well, we've been talking about that. The slope of position time is velocity. You can't just say slope is velocity, because there's different graphs that we're talking about now. Slope of position versus time is velocity. Right? That's how we got these. How we figured out where we should be making our horizontal lines. Looking at the velocity time graphs, determine the units for a square of area on the graph. That's a tricky question. If you didn't figure out what to do with that, I would not beat yourself up there. So I'm just going to borrow one of these graphs here. So what they're saying is, look at the velocity time graphs, determine the units for a square of area. So if you're talking about area on one of these graphs, like there's 1 square unit of area on this graph. Now I want you to think about how you find area. How do you find area? Area is a multiplication operation. How about slope? Slope is a division operation, right? It's rise over run. It's something divided by something else. When you're finding area, you're doing like a length times width thing. It's a multiplication operation. So here, this side of this square, that's an up-down thing. That would have units of meters per second, whatever this is, like 1. And then here, this has units of time. And if you want to find area, you're multiplying these together, right? So the units here would be the units of rise, meters per second, multiplied by the units of run. Not rise over run in this case, but rise times run. That would find that little area. And the units of run are seconds. Now meters per second times seconds is equal to meters. So whatever this area is, whatever that means, the units of it would have to be meters. All right. What does the area under the velocity time graph tell you about the motion of an object? Well, let's look at the simplest one of these graphs, maybe the first one. So when they're talking about here the area between the line and the horizontal axis. So here, that's between the line, that's right here, and here's the horizontal axis. So we would be talking about here, if we wanted to talk about the area for the first 5 seconds, That would be this area. Okay, what is that area? Well, it's 1 meter per second times 5 seconds. So that would be 1 by 5, that's 5. Now what does that mean in this situation? This is, oh, you know what? In this one it only went up to 4 seconds, so I should have stopped here. So instead of 1 to 5, or 0 to, we should just do this much and forget about that. So what does it mean that the area of this rectangle right here is 4, and the units must be meters? 4 meters. Well, that's what its displacement is. That's from here to here. That's how far it went. And then here, if you look at this graph, what's the area here between the line and the horizontal axis? There's that part of it. And then here's the horizontal axis, and here's the line down here. So this area is actually underneath. What does that mean? Well, here, this is 1 high and 2 wide, so that would be 2 meters. And then the area of this is 2 wide, and I guess it's kind of like it's -2 high, right? It's weird to have negative area, but this is in negative territory. So -2 times 2 is -4 meters. So what do these areas mean? Well, 2 meters, that's it going up 2 meters right there, and -4 going from here back to here. And if you add them all up, if you add up all the area, 2 minus 4 is -2. That's like from here 2 to 0. That describes what happened from when it started to when it ended. It went from 2 to 0. That's a displacement of -2. So that's what it means. What does area under the velocity time graph? So area under velocity versus time is equal to displacement. Cool.